My name is Arvind Chandran. I'm head of motion planning at Motion. I lead a team that develops driving systems which enable autonomous vehicles to navigate safely and efficiently in complex environments. I always had a fascination for robotics and intelligent systems. I was at the last year of my master's. Autonomous driving field was picking up at the same time, so it was a combination of interest and timing. Motion planning is one of the key components of driving function. It essentially plans how an autonomous vehicle should navigate in the environment while considering safety and feasibility, and at the same time following the traffic rules. The motion planning takes the input of the awareness of the environment around it, which includes the lane information about the obstacles, about the traffic conditions, and translates that into an output, which is essentially a plan of how to act in the near future. And it represents this output as a trajectory. We can also call it a temporal path. Basically, a path is a set of points. Each point is planned in time. So it's like a time-based path. That's what a trajectory is. Motion planning is the function, and trajectory is the output of this function.
One of the inputs to motion planning comes from a decision module, which is an AI-based trajectory input.
And motion planner also actively adapts its path for changing traffic circumstances, creating new paths as the traffic context unfolds. We use three different ways of validating motion planning. The first way is the simulation testing, and second being testing it on a closed-loop test track, and third is real-world testing. Simulation provides us flexibility to create new scenarios. Closed-loop testing is mainly focused on how well the planned paths are executed and how well the motion control functions. This lets us know whether the planned paths are within the scope of the vehicle's capabilities. Real-world testing is the most crucial aspect, where we actually get real-world feedback on how well our functions perform. Behavior planning decides on what a vehicle should do on a very high level, while a motion planner plans exactly how this action has to be executed. Stateless means there's no memory of the past. Motion planner is relatively more stateless because it has to adapt to the environment quickly, whereas the behavior planner has to hold memory of its past intent to maintain a more coherent behavior. We develop explainable systems, which are a combination of AI and conventional methods with a lot of guardrails to protect our system so that we always behave safely. If something goes wrong, we have a way to trace back where things went wrong. We also have ownership of sensor installation design and driver system, the two extremes. Most companies outsource these. Since we have control over these things, that gives us this additional layer of flexibility that helps us to modify and scale up to new vehicle platforms in the future.